Students, now continuing with exercise 6.1. Question number 6. Identify which of the following expressions are polynomials. We need to find in this question that which expressions are actually the polynomials. And if they are polynomials, if so, write their degree. So this is the second question. First of all, we need to find whether the given expressions on the board are polynomials, and if they are polynomial, then I have to find their degree. Fine. So the basic thing over here is, let's see that whether in the question number 6 the given expressions are polynomials or not. So before writing the sub questions of question number 6 on the board, I like to give a small note on the board, where after that you can easily rectify which expressions are polynomial and which are not. Okay, the note is in front of you on the board. Students, now two notes we have on the board. These are the conditions for becoming polynomials. Every expression cannot be said as polynomials. What are the conditions? Let's see, students. The first condition, the expression should have two or more terms. Yes, if I have suppose 7x square, this is my one term. Can this be called as polynomial? No, because it has only one term. So I'll extend it plus 5. Yeah, now we have two terms. So this is one term, this is second term. So minimum we should have two terms. Minimum it should be a binomial. Then only it can be called as polynomial. So minimum we should have two terms or more than two terms. So two or more terms should be there. Minimum there should be two terms. This is the first condition. And second condition, and here also we'll see some examples over here. Power of variables should be positive integers. Okay, for example, I'll say 7x square plus 3y square. Here I have two variables x and y, and both has power 2. It can be the case that this has power 3. It does not matter. But the powers, the individual degrees of this term is 2 and individual degree of this term is 3. It's a positive integer. Positive integers means it can be 0, 1, 2 and all positive numbers. It goes on. Okay, for example, I give you I have an expression like 7x square plus 6y square minus 3 minus, okay, let's say plus 5z raised to minus 2. Is this a polynomial? See, I don't have any problem with this. The power is positive integer. Here with the variable y has power positive integer 2. It's minus 3. Here the power of this variable z is minus 2. It is a negative integer. Because of this term, in this term, the power of the variable is a negative integer. So this is not a polynomial. Please pause the video, students, and copy everything from the board. So students, the next question is on the board. Question number 1, x square plus 1 upon x square plus 1. This is the first question of exercise 6.1, question number 6. The first question, we need to identify which of the following expressions are polynomial. And if they are polynomial, then the second chapter with us, the second topic is we need to find its degree. Okay, x square plus 1 upon x square plus 1. Here with the green color on the right hand side, I have written the two conditions. The first condition is there should be two or more terms. Do we have two or more terms? Yes, this is my first term, this is my second term, this is my third term. So students, can I say I have more than two terms? But it should be minimum two terms. So definitely this first condition is satisfied, that this is a polynomial. Okay, great. Now let's move on to the second condition. It should have positive power. Apparently, students, this is important sum. Apparently, if you see, you'll say, sir, the powers are positive. Here the power is 2 positive, here the power is 2 positive. But students, the variable which is x in this sum, the x, the alphabet, the variable cannot be in the denominator. All the variables should be in the numerators. It cannot be in the denominator. So students, pay attention very carefully. Here, before solving this, I am solving one note over here. Please listen to this. This is a very simple thing which you all have already studied in 6th standard. See here, please. If I have 1 upon a raised to minus 3. If I have 1 upon a raised to minus 3, and if I bring this a from numerator to denominator, if I am bringing this a from numerator to denominator, this will become a raised to plus 3. A raised to minus 3. This minus 3 got converted into plus 3 because we had done a change in state from denominator to numerator. Let's see another example. I have 7 upon 6 raised 7 upon, for example, b raised to 3. And now if somebody tells me that bring this b in the numerator, so we have already a 7 in the numerator, 7 will remain 7. I repeat my question again. I have 7 upon b raised to 3. Somebody tells to me you need to bring this b in the numerator. Okay, so 7 in the numerator remains as it is, this 7. Okay, now I am bringing this b raised to 3 in the numerator. This will become b raised to minus 3. A minus will be introduced in the power, that's it. This minus 3 became plus 3 when a comes up. Obviously here originally it was a 1. So we can just write 1 multiply by a, same thing. So that's the reason I did not write first. 7 remained as it is, 7 only in the numerator. The denominator, which is b raised to 3, I am bringing it in the numerator. So this b raised to 3 becomes b raised to minus 3. Obviously it's multiplication in between them. So whenever there is a change in state, okay, we can also go vice versa. For example, a raised to 7 upon 6. So if I need to bring this a raised to 7 down, this will become 1 upon 6 is already there here, a raised to minus 7. If a raised to 7 comes down, it becomes a raised to minus 7. So you should have this logic in your mind. After this question, when I'll say pause the video, at that time please copy this note also. Okay, come here students, let's see here. Can I say over here, this can be written as x square plus the x square over here, the x is in the denominator, so I need to bring in the numerator. So when x square goes in the numerator, it will become x raised to minus 2 plus 1. That's it students, that's it. Now you all can see the power became negative, and our condition was positive power. So that's the reason it is not a polynomial. Okay, so as power is negative, it's not a polynomial. Great. Okay, now let's solve the second question also. Afterwards you all can pause the video and copy this note and everything together. The second question which I'll be solving on the board is your textbook sub question F. Sub question F of your textbook. It's 17x square plus 16 upon y square plus z square. See, we have 3 variables, x, y and z. Great, no issues. Our first condition is we should have 2 or more terms. First term, second term, third term. Yes, we have three terms. So first condition is satisfied. Second, the powers should be positive. Now let's check. Can I say variable is here down? This is not done. We should have all the variables in the numerator. So can I say students, once again, I need to bring this y square in the numerator. So when I change the state from denominator to numerator or from numerator to denominator, what happens? The power ka sign changes. See, when it was minus 3, when we brought in the numerator, it becomes plus 3. When it was b raised to 3, when we brought in the numerator, it becomes minus 3. When it was a raised to 7 in the numerator, when I brought it down, it becomes a raised to minus 7. So always the sign changes. So when I will bring this y raised to 2 in the numerator, it will become y raised to minus 2. Pay attention here students. So 17x square plus 16 already in the numerator, I load 16, multiply by y raised to 2 goes in the numerator, becomes y raised to minus 2 plus z square. Now students, the same case that we have here, as the power is negative, students, you have to write the reason. We will copy this reason as it is, that as the power is negative, okay, so it is not a, you have to write the reason. As the power is negative, so it's not a polynomial. Okay, please pause the video students and copy everything from the board. Students, now the next question on the board, it's sub question C of your textbook. Sub question C, minus 3x square plus 2x cube. Okay, let us check first whether it satisfies the first condition. To become a polynomial, the first condition is we should have two or more terms. Yes, this is the first term, this is the second term, so I have two terms. So minimum there should be two terms. So of course this is a polynomial as far as the first condition is concerned. The first condition is satisfied. Now let's see the second condition. The second condition is positive powers. The powers should be positive. Let's check this. Students, pay attention, only power ka word is mentioned here, power. So don't say that, sir, we have a minus sign. This minus is with 3. It's like minus 3x square. So minus can be with the term, but we are talking about the powers. Power here is plus 2. Okay, here the power is plus 3. Okay, so powers are positive. So therefore it's a polynomial. Now students, here comes a very important case. Please pay attention. All of you, please pay attention. We need to find now the degree also. It's mentioned here that if so, that means if this is a polynomial, then write the degree. Now how to find degree? Please pay attention. Please pay attention. We have to individually, mark my words, we have to individually find degrees of terms. Okay, we have to find degree of individual term. This is my first term. Okay, this is my second term. Please pay attention on this red boxes. This is my first term. This is my second term. We have to find the degrees of individual terms. Okay, so first step is what we have to do. Find degree of individual term. Okay, and second step will be highest will be considered as degree of given polynomial. Pay attention to this note, students. The first step is find the degree of individual term. Find the degree of individual term, and second step is highest degree will be considered as the degree of given polynomial. Degree of given polynomial or degree of entire polynomial. Okay, be calm. Let us understand the first term. First step first. Find the degree of individual term. Okay, students, now I am finding the degree of individual terms. Pay attention here. This is the first term, minus 3x square. Of course, we have to see the variable. Variable is x. What is the power of x? 2. So degree of this is 2. Yeah, you all can write this in exam also. No need to erase. With the pencil you can write. Okay, the degree here with this term is 2. Okay, if we come here, the variable is of course x only, and the power is 3. Power and degree is one and the same. So here the degree is 3, power is 3. So first step is done. We find out the degree of individual terms. Iska degree is 2, this term ka degree is 3. Okay. Highest degree from this 2, what is the highest? What is the largest value? 2 is bigger one value or 3 is the bigger value? Of course 3 is the bigger value. So see here, the highest degree will be considered as degree of given polynomial. So therefore degree of given polynomial is how much? The highest one, the largest one, which is 3. Okay, so now I think so you understood the scenario. The two steps are, first find the degree of individual terms. Iska degree is 2 and degree for this is 3. Second, from the terms which you have and from the degrees which you have find it out, what you have to do, you have to select the largest value. So 2 from 2 and 3 was the largest value. Highest degree among the terms will be considered as the degree of given polynomial. So 3 is the answer. Please pause the video, students, and do it, and don't forget to write this as a note. Students, now the next question on the board is sub question I, 14x plus 7y plus z minus 21. Okay, first we need to decide whether this is a polynomial or not. What are the conditions? The first condition is we should have 2 or more terms. Okay, students, now you all tell me that do we have 2 or more terms? Yes, we have 1, 2, 3 and 4. 1, this is my first term, this is my second term, this is my third term, and this is my fourth term. We have 1, 2, 3, 4 terms. So it satisfies the first condition. Second condition, it should have positive power. Here the variable power means degree. Both are synonyms. Okay, both are synonyms. And power or degree is always with the variables, with the alphabets. Here the power of x is what? I am asking you, please let me know. Here when nothing is written on x, it is 1. Don't say it's 0. So here power of x is 1. When nothing is mentioned, by default it's 1. When nothing is mentioned as a power of y, it's 1. When nothing is mentioned as a power of z, it's 1. Okay, but here we have no variables. Here we have no variables. So because we have no variables, that means the degree or power is 0. Please mark this. Here that means the whatever the variable it would be there here. It's not mentioned here. But the power of that variables will be 0 because anything raised to 0 is 1. It can be the case that it will be 21 x, y, z and power of x is 0, power of y is 0, power of z is 0. I'm just assuming. It can be the case it would be 21 mn, power of m is 0, power of n is 0. It can be any variables over here, but the powers will be 0 and anything raised to 0 is 1. So they have not written anything, they have just, it's a 1. It's 1. That's the reason there is nothing mentioned here. Okay, so 21 ones is 1 only, so 1 also they have not mentioned. In short, to summarize the discussion, when no variables are mentioned, keep in your mind the degree of that term is 0. Degree of this term is 0. Okay, so here we have nothing. That means whatever the variable it would be there here, the degree of that variable will be 0. And because anything raised to 0 in maths is 1, so they have not mentioned it. So in short, the degree of this term is 0. Okay, degree of this term is 0. Okay, so now let's proceed. Okay, can I say 0? I told the degree is 0 and 0 is also a positive, 0 is also an integer. 0 is also an integer. And we are fine. When I say I want positive power, so 0 can also be there. When I say positive power, 0 can also be there over here. So that means both the conditions are satisfied. So this is a polynomial. Okay. Now it's a polynomial. So let me write the answer. It's a polynomial. Okay. Next. Now I need to find the degree. For finding out the degree, I'll rewrite this given expression. 14x raised to 1. This 1 with orange color, I wrote on the board. Okay. It was not given. Plus 7y raised to 1 plus z raised to 1 minus 21. Okay, this is a given question. Okay, students. Now let's find the degree. Now to find the degree, we have two steps here. Let me reiterate this. Find degree of individual terms. Find degree of individual terms. Okay. Can I say this is my first term, this is my second term, this is my third term, this is my fourth term? Students, degree of this term, who will give us the degree? The power of the variable, x ka power is 1, so here the degree of this is 1. Here the variable is y and its power is 1. So degree of this term, only this term 7y is 1. Here it's z and the power is 1. So degree of only this term is 1. Here we have no variables. That means I told you degree is 0. Okay. So we found out the individual degrees. Degree of this term is 1. Degree of this term is 1. Degree of this term is 1. Degree of this term is 0. Now don't say that the degree of the complete polynomial is addition. No. We will not add. See the second step. See the second step. Highest degree will be considered as degree of given polynomial. So from 1, 1, 1, 0, what is the highest value? Of course 1 is the highest value. So I'll say 1 is the degree of complete polynomial. So degree is 1. Degree of complete polynomial is 1. We have to select the highest one from all the different degrees which we found out. Hope you understood, students. Pause the video and please start. Students, the next question on the board, it's sub-question G. It's sub-question G. Okay, on the board. Students, before starting this question, I'll mark this sum very, very important. I have marked a star over here. Very, very important question. Okay. Why is it so? You will understand. Now, understand first. First, we need to decide whether this is a polynomial or not. Let's see. The first condition is it should have 2 or more terms. Students, it's very simple. We have here, this is first term, this is a second term, This is our third term. Students, don't say like this that x is one term and y is second term. Between x and y we have multiplication, and multiply and division does not decides the term. Plus and minus sign decides the term. Plus and minus sign bifurcates the terms, segregates the terms. So x square multiply y cube, because we have multiplication, so this is entire one term. This is my second term, this is my third term. Here three things are multiplied, 3x and y square. This all is one term. So total we have first, second and third. We have three terms. We should have minimum two terms. So of course this is a polynomial as far as the first condition is concerned. Now second condition is it should have positive power. Now students, you tell me, say I'll mark some things on the board. What is the power of this? We are talking about this first term. What is the power of this x? Positive 2. Power of this y? Positive 3. Power of this y? Positive 2. Power of this x? Positive 3. Power 3, in 3 we don't see the power. 3 is a number. We always see the power for the variables, alphabets. X. There is nothing written over x. When there is nothing written, where there is no one, there is always 1. So it's 1. And y, it's written 2. Can I say 2, 3, 2, 3, 1, 2, all are the powers and all are positive. So both the conditions are satisfied. Therefore, it's a polynomial. It's a polynomial. Okay. Now students, let's decide about degrees. Okay. So to talk about the degrees, I'll once again rewrite the given expression. The given expression is x square y cube, okay, plus y square x cube plus 3x y square, and I wrote here 1, so the same one I'm copying here, x is to 1 y square. Okay students, so this is our case. Now students, please pay attention, very important scenario, pay attention. It's a polynomial. Now I need to decide its degree. There are two steps to find degree. Step number 1, eyes on the board, all of you eyes on the board. There we have three terms. This is first term, this is second term, this is third term. Step 1, find degree of individual terms. So this is my first individual term, second individual term, third individual term. Let's find the degree of this. This is the first time we are encountering in one term two different variables. Pay attention. If at all I was having only x square, so I would have written 2, the power of 2, the power of x is 2, so I would have written 2. If at all I would have only y cube, so I would just have written power as 3, the degree as 3. But here I have x as well as y, I have two variables. So I cannot ignore both the powers. I cannot say, oh x I will take you, oh y you go. No, I cannot say that. I have to take both. So I am doing the first term, first step. Find degree of individual terms. So what will be the degree of this term? Degree of this term will be 2 plus 3 is equal to 5. How come 2 plus 3? We have two variables. In the previous questions, in one term we were having only one variable. So we just see the power and we write it as a degree. But here we have two variables. Power of x is 2, power of y is 3. So 2 plus 3 is 5. So degree or power of this entire term is 5. Similarly, power of this variable y is 2. Power of this variable x is 3. So I have to consider both the powers, because I have to find the complete power, complete degree of this term. So it will be 2 from y and 3 from x. Once again comes to 5. And over here, of course, it's 3 is a number. We don't have powers of number. We don't consider the word, this is correct. We don't consider. We just see the alphabets. So power of x is 1, okay, plus power of y is 2. So this becomes 1 plus 2 as 3. See here students how I found out the individual terms ka power or individual terms ka degree. Degree of this individual term is 5. How come? 2 was the power or degree of x. 3 was the power of or degree of y. So 2 plus 3 comes to 5. 2 plus 3 comes to 5. 1 plus 2 comes to 3. Okay. So right now I've got the individual terms ka degree. Degree of this term is 5, degree of this term is 5, degree of this term is 3. Second step, pay attention. The highest degree will be considered as degree of given polynomials. So we just have to see the highest one. From 5, 5, 3. 5, 5, 3. What is the highest value? Of course 5 is the highest. So degree of the entire polynomial is nothing but the highest one, and it's 5. Degree is equal to 5. It was a very important question, students. Please pause the video and do it by yourself. Students, now on the board we have a new question, question number 7. I'll definitely mark this question also as an important question. Okay, the expression is given on the board. See the expression: 5x square y square minus 3x cube y cube plus 6x square y square minus 2xy plus 7. Okay, a huge expression is given to us. Okay, the first sub question, I have just written the questions on the board. The first sub question A is find the number of terms. Number of terms, it's very simple. Okay, once again I repeat, 5 is multiplied with x square and x square is multiplied with y square. So when nothing is mentioned, that means it's multiplication, and multiplication and division does not makes a term. Okay, so you will not say this is 5 is one first term, x is second term, this is third term. No, this complete is one term. First term, second term, third term, fourth term, fifth term. Plus minus makes terms. So even though I have only 7, poor fellow, alone, but because we have plus in between here, this is a plus, so it makes a different term. So first, second, third, fourth, fifth, I have 5 terms. So answer for the first one is 5 terms. Number of terms is equal to 5 at present on the board. Okay. Numerical coefficient of y square x square. The first thing I need to make you all aware about is, if I say 5 multiplied by 7, just don't see over there, I'm not teaching anything from the board, it's a note from my side. If I say 5 multiplied by 7, it will be what? 5 sevens are 35. If I say 7 multiplied by 5, it will be what? It will be same 35. That means in multiplication, if you multiply 5 with 7 or you multiply 7 with 5, it's one and the same. The technical word in maths is commutative. Multiplication is commutative in algebra. 5 and 7 are commutative in nature. We can commute them, we can change their places. So either 5 is the pre one and 7 is the post person, and or either 7 and 7 becomes the pre number and 5 becomes the post number. Answer will be same. Similarly, students, why I gave you this note, why I explained you this, see on the board. Similarly, students, here it is asked, find the numerical coefficient. Find the numerical coefficient of y square x square. Y square multiplied by x square. Can I say it also can be the case like x square multiplied by y square? It's one and the same. Y square multiplied by x square bolo, yeah, x square multiplied by y square bolo, it's one and the same. I gave you the reason here, because multiplication can change the place. 5 into 7 is same and 7 into 5 is also same. Okay, this is only for the multiplication, huh? Don't use it, please, don't misuse it in other operations. Okay, so now let's do it. I erase this stuff from the board. Okay, so now I have to find numerical coefficient. I emphasize on this word numerical. Numerical means the number. I just have to see the number. I want to see the number associated. Coefficient means partner or friend. The numerical friend of y square x square or x square y square. It's one and the same. So let's see. Do you have y square x square? Y square x square, y square x square, y square x square, y square x square, y square x square? No, I don't have. But do we have x square y square? It's one and the same. Yes, I have here. Yeah, I have here. Let me highlight it. With blue color. Yes, this is x square y square, and this is also x square y square. Okay, we just have to see the numerical coefficient, the number, which is coefficient means friend of x square y square. What is the number associated with x square y square? Here it's 5. Okay, it's 5, and here it is plus 6. Don't forget to take the sign plus 6. Here also it's plus 5 because no sign is mentioned. So here it's plus 5 and here it's plus 6. We have two different terms with x square y square. So here we need to find numerical coefficient. So I'll write plus 5 and plus 6. Okay, which comes to plus 11. This is our answer. Students, this is our answer. The numerical coefficient of term x square y square or y square x square is 5 plus 6, which is plus 11. It's fine if you don't write this plus 5. Answer is plus 11. Okay. The next is question is it a polynomial? For the polynomial there should be two cases. Minimum there should be two terms. We have great number of terms here, 5 number of terms. Is it a polynomial? Yes, it is a polynomial. Yes. And second condition, of course, it is that the powers of each term should be positive. 2 is positive, 2 is positive, 3 positive, 3 positive, 2 positive, 2 positive. Nothing mentioned on x means it's 1. Nothing mentioned on y, that means it's 1. Nothing, no variables, that means power is 0. It's also, it comes in our case. So all powers are positive integers. So yes, it's a this is my first answer, polynomial. Okay. If so, find the degree. If so, find the degree. Find the degree. Okay, pay attention here, students. I have to find its degree. So to find its degree, I'll rewrite the given polynomial here once again. Pay attention. It's 5x square y square minus 3x cube y cube plus 6 x square y square minus 2 xy plus 7. Here nothing is mentioned on x means it's 1. Nothing is mentioned on y means it's 1. 5x square y square minus 3x cube y cube plus 6x square y square minus 2xy plus 7. Great. Now in the previous part, in the previous question number 6, I have written a note on the right hand side over here that there are two steps to find the degree of the complete polynomial. Step number 1 was to find the degree of individual terms. So let's find out the degree of individual terms. This is my first term, this is my second term, this is my third term, this is my fourth term, and this poor fellow is the last one, fifth term. Okay, students, now let's find the degrees. Okay, how to find degrees? When we have two variables, we just saw last question of question number 6. Here x and y, we have two variables, so we have to consider the powers of both. Here it's 2 and here is 2, so 2 plus 2 becomes 4. So 4 is the degree of this term. Come on here, we'll not see this minus, we'll not see this 3, we only see the powers of variables. Here the power of x is 3, here the power of y is 3, two variables, so we have to consider both the powers. So 3 plus 3 becomes 6. Here the power of x is 2, here the power of y is 2, 2 plus 2 becomes 4. Here the power of x is 1, here the power of y is 1, 1 plus 1 becomes 2. Here when no variables are given, always remember the power will be 0, power will be 0 because no variables are given. Okay, second step was after finding the individual terms ka degree, degree of this term only is 4, 6, 4, 2, 0. What we have to do? We have to find the highest one. Whatever degree we get as the highest degree, comparing all the different terms, that degree will be considered as the degree for the entire polynomial. So therefore, degree of the entire polynomial is 6. Okay, degree for the entire polynomial is 6. And last one, sub question D. Okay, sub question D. Please pay attention, it's very simple. Eyes on the board. Write the coefficient of x square. The word coefficient is mentioned. Students, pay attention. In sub question B, the word numerical coefficient was mentioned. अगर word numerical आता है तो we just see the number वाला friend. But here the numerical का word is not mentioned. Here just coefficient is mentioned. That means all the friends will be allowed. Either it will be alphabets, that is the variables, or the numbers. Both we have to consider. Because your word numerical is not mentioned as a sub question B. So write all the friends, or write all the coefficients of x square in this. So we just don't have to refer this complete polynomial. We just have to compare this two, the blue box with this red box. So just delete x square from this expression, minus 3x cube y square. So what will be remaining? That those are the friends. So the solution will be coefficient of x square is, I'll write here. See, let's compare. Do I have here minus? No, I don't have minus here, but I have minus here. Here I have 3. Do I have 3 here? No, I don't have 3. So I write 3 here. Here it is x cube. It's x cube written over here. Do I have here x cube? No, I have x square. 2 times I have x. Here it's only 1 time. So I write only 1 time. Because it was 1 time extra. I have y square here. Do I have y square here? No. So y square. This is my answer. So apart from x square, just omit out this x square. What all things are remaining here? They becomes the friends which are associated with x square, the coefficient of x square. So minus 3 was not here. Here there was 3 times x. Here it's 2 times x. So 1 time x. Here it was y square, and here there was no y. So y square. This is called as the coefficient, okay, of x square. Important sum. Please pause the video, students, and complete it first.